Hello, welcome to the beginning of Unit 4. This unit we're going to start talking about two variables being measured at the same time and the relationships between the two of them. Some examples of that I've got written up here. One of the examples that are in your notes are saying that do heart attacks or heart problems happen more frequently for shorter women than average sized women? And those two variables that we're looking at are the frequency of heart attacks and height, and how the two of them may be related. Other examples, the number of car deaths versus the weight of a car. Is there a connection between those two? One that you guys will understand and know, is there a correlation or relationship between the amount of time studying and test score? The main part about this unit is taking two variables that are measuring different things and seeing if there's a relationship between those. Now we'll talk about different equations we can use and things that are called correlation and regression to see mathematically what that would be. But visually, one way we can do that is by looking at a scatter plot. And so I came up with some numbers right here. The amount of time studying and test score. And we want to look and see, is there a relationship between the amount of time that someone studies and the test score that they get? What we can do is we can look at this visually, and that's what a scatter plot is doing. A scatter plot is giving us a visual representation of this. To let you know, when we're making a scatter plot, we're putting one of our variables on the bottom. This is normally going to be the variable that we think is causing the other. On our notes, we have that is called the explanatory variable. It's the one that explains the other. And for us, this would be study time. We think the study time in hours is going to explain the y value in this case, which is the test score itself. And that would count as our response variable. The definitions are going to be there in the PowerPoint, and one of the things that's important of this is knowing that if there is going to be a cause and effect relationship, the cause is always going to be your x, and the effect is always going to be your y. Now, it's not always going to happen where one causes the other, but if you see that connection, this is the order we need to have it, where the explanatory variable is our x, and our response variable is our y. So for this, what we want to do is we want to plot all of these points on our graph and see if that shows us any sort of connection. So we plot each of them together, 172, 0.564, 175, 1.574, 278, 276, 276, 3.589, 171, and 0.570. And as we look at this, now if it's hard for you to see, I suggest you plot this on your own paper so you can really see where these points are. We're using a graph and we're just plotting the points as is. What we see that happens is we see that there's a trend. The trend follows an upward direction here, which we can use this and we can analyze this by saying that the more we study, the higher test score we get based on this data. Now I just made this data up, but if we were to go and collect our own data, we might see this trend also being in play if we had a lot of numbers. Now again, one thing that was going to make this kind of difficult is if you don't have a large sample size. And what we want to do, just like in other areas in statistics, is make sure our sample size is large enough so that an individual point doesn't mess with our data if we're going and collecting it. Like I said, sometimes there will not be an explanatory and response variable that makes sense with each other. Part of our homework is going to be determining if there is an explanatory and response variable relationship that makes sense. Just to give you an idea, some places where there isn't really where one explains the other or one causes the other. And these are types of events that would not have explanatory and response variables. When are they not going to be? That's going to be when they both vary together. Some examples of those would be the height and weight of different people. They're going to vary at the same time, and one doesn't necessarily cause the other. Second is going to be if you're looking at multiple test scores, so like the SAT test scores and the ACT test scores, you may see that there's a relationship like this, where the higher you get in one, the higher you get in the other. But that doesn't mean one is the cause and one is the effect, or the explanatory and response variables. And then the last one example that we may see is two different weather phenomena happening at the same time. So like the amount of rainfall in a certain region and the temperature in a certain region. Now those two are going to be connected. There's going to be a relationship, but that doesn't mean that one causes the other. And so part of our homework is, at least right now, determining does it look like one causes the other, or do they both just vary separately?